Welcome to the Module 15 Part 3 notes. In this section, we will look at how to do a hypothesis test for a mean. Module 12, the mean of the distribution of the sample mean is equal to the population mean. The standard error is the standard deviation of the population over the square root of n. The central limit theorem says our distribution is normal if we have a sample size of at least 30 or our population is known to be normal. And the z-score equation was the sample mean minus the mean of the distribution or the population mean divided by the standard error. So sigma over the square root of n. Now we have a problem with these notes, or not with these notes, with this z-score equation. It's going to be hard enough for us to know what the population mean is. It's going to be pretty much impossible for us to know what the standard deviation of the population is. So instead, what we're going to do is we are going to substitute the sample standard deviation for the population standard deviation. And that changes our distribution from the normal distribution to a t-distribution. And a t-score, which still tells you how far away from the mean you are, is as follows. You take your sample mean minus your population mean and divide that by the sample standard deviation over the square root of n. So now this t-distribution is still bell-shaped. It is still centered and symmetric about a t-score at 0, which is the mean. The total area under the curve is 1. But as the t-distribution gets closer to the normal distribution, so as the sample size increases, I said that wrong. As the sample size increases, the t-distribution gets closer to the normal. So what does this mean? Well, it means if I draw a normal curve, and I'm going to do it down here because we're not actually going to do this example. If I draw a normal curve, okay, looks something like that. Not exact, but close enough. A t-curve where I take a sample of 30 might look something like this. So with this distribution, the mean is still in the middle, but now it's a lot more squished and a lot more spread out. So there's a lot more area in these tails on the outsides, and there's a lot more variation from sample to sample. If I take a sample of 100, then the t-curve looks a little bit closer to the normal curve. And then finally, if I take a sample of size 1000, my t-curve is even closer. So the t-curve is going to change depending on the sample size. And we call this the degrees of freedom. And the degrees of freedom is equal to the sample size minus 1. So for what we're going to do with this hypothesis testing, we're going to need to know the degrees of freedom. And we're just going to need to remember that we're now using a t-distribution, not a normal curve, because we don't know the population standard deviation. So we have to substitute the sample standard deviation instead. All right? So now examples 1